So thank you everyone for coming. Today we have NRAO, National Radio Astronomy Observatory representatives, Valarie Bogan and Chris DePree here. And I will stop talking and hand it over to you.
All right, thank you. Let me go ahead and share my screen. There we go. Um, Thank you, Chris, for having us. It's really great to be here. Um, so we're going to be talking about some opportunities for all of you to become involved in what we do at NRAO. And just to give everybody an idea before we get started at the agenda, so you know what's coming toward you, and if you need to duck out, when might be a good time to do that. So we'll do introductions first, and then Chris is going to tell you about spectrum management and NRAO. I'll tell you about some free courses that we have available for you to use, as well as for your students. We'll talk about the summer student programs that we have available, EPO tours that are available at our properties, and then we will actually try out some of our citizen science projects. So I hope all of you have your cell phone near you, because we'll be doing some activities with that when we get to that point in the presentation. So it's a small group, and I'd like to take just a few minutes, if we could, and just introduce ourselves so that actually even stop sharing so we can see each other. Tell us your name, your institution, and where you are in the world. What state you're at. So just to give myself a geographic understanding of where everybody is, that would be great. And feel free to unmute yourself and do so. So I will go ahead and start since I'm already talking. My name is Valarie Bogan. I'm the Curriculum Program Manager at the National Radio Astronomy Observatory, or NRAO, as we like to affectionately call it. I do all types of curriculum, from K-12 to citizen science to organizing undergrad and graduate courses. And I am a remote employee, and I'm currently located in the state of Indiana. All right, Chris DePree.
Hey, I'm Chris DePree. I'm Deputy Spectrum Manager for NRAO, taught undergraduate physics and astronomy at Agnes Scott College for 25 years before that, now based in Charlottesville.
Before I get Chris started, explain to you why he's going to be talking to you about spectrum management, because we both work for a radio astronomy organization. But although NRAO is known for the telescopes, like the ones in New Mexico and West Virginia, and even in Chile, it's not all we do. There are so many other things that we do in NRAO. We have engineers that develop components for antennas and make some amazing programs. We've got computer scientists, we've got education people, and all the support staff that work behind the scenes. And so NRAO is a very diverse group as far as disciplines. And spectrum management is becoming something we are more interested in these days, because the spectrum is becoming crowded and NRAO needs the radio frequencies to do what we do. And so this is a field that we have delved into, and it's becoming more something we spend our time on. And there's actually a lot of career opportunities in spectrum management. So with that, I'm going to turn it over to Chris DePree, who, as he told you, is the Deputy Spectrum Manager here at NRAO, to give you an introduction.
All right. Thanks, Valarie. Yeah, as I said, I've been at NRAO for, let me go ahead and start this, going on 4 years now. Before that, I was teaching physics and astronomy and running the on-campus observatory at Agnes Scott College. So doing the kind of work that all of you were doing for a long time. And I appreciate the importance of that work, and also how challenging it can be sometimes with resources and other challenges. And I'm also really excited to see that several of you who are retired are still really involved in this important venture. So I'm going to talk to you today about electromagnetic spectrum management at NRAO, and sort of the kinds of things that that we do here. So first of all, it may not be a familiar topic. Just a quick definition. What is electromagnetic spectrum management? It's basically the process of managing the use of radio spectrum. And from the point of view of radio astronomy, we're trying to minimize harmful interference. And if you can imagine, the spectrum has many demands on it, right? We have both passive users like radio astronomy that's hoping to have the quietest spectrum possible. You have active users like not only cell phone companies and companies that build electronic devices, but now also orbiting satellite constellations, right? So radio waves are an incredible way to move information from point A to point B without the expense and infrastructure of solid connections, right? Optical fiber, Ethernet cables, all those sorts of things. So spectrum management, there are a couple ways to kind of protect the spectrum for passive users, one of which is the allocation of frequency bands to radio services. So one way to do this is to say, okay, we have spectrum, let's divvy it up. You get this part, I get this part, this other person gets that part. And that's how spectrum management worked for decades, really, since radio interference was known about and radio was used to transmit information. There's a lot of national and international effort that goes into writing rules for the compatible use of allocated bands, right, that keep people out of each other's way. And one thing that radio astronomy has benefited from is that there are some interference-free assignments, frequency assignments. So there are parts of the spectrum, it's not much. Below 100 gigahertz, it's about 1% of the radio spectrum is actually allocated only to radio astronomy. Other people are not supposed to be there. And this is at particularly important spectral bands that I'm sure some of you are aware of, like the neutral hydrogen line, right? This occurs at 21 centimeters or in around 1.4 gigahertz. So, I mean, if you think about what's happened in the world in the past couple of decades, wireless communications have exploded, right? We all have these things on our wrists and we all have cell phones in our pockets and they're all using Bluetooth and Wi-Fi and all sorts and cell phone bands, right? So all sorts of bands that used to be fairly quiet are becoming increasingly full of transmissions. And that is certainly a challenge for radio astronomy. So this is the kind of dizzying frequency allocation chart that that the United States Department of Commerce puts out, and it runs from 0 kilohertz way at the very, very low frequencies all the way up to 300 gigahertz. And so you can see that at these higher frequencies, things get incredibly crowded, right? Very narrow bands with lots of contiguous users. If you look for the little yellow bands, those are radio astronomy. So here's a radio astronomy band here. There's a radio astronomy band, very famous one, which is the one I mentioned earlier, that's for the H1 line. So all throughout the spectrum, there are radio allocations. And in fact, at higher frequencies, more of the spectrum is in fact set aside for radio astronomy. But as one particular band that we've been very interested in lately, this is just a detail of that other plot, from 10.7 to 12.7 gigahertz are frequencies where satellites downlink. So you've probably heard of the SpaceX Starlink system for broadband internet. They are downlinked from 10.7 to 12.7 gigahertz. And you notice here, radio astronomy actually has an allocation. 3 passive services are allocated right up to 10.7 gigahertz. Because of that proximity, all of these satellite companies have been required by the FCC to communicate with us and coordinate with us their use of the spectrum in those bands, and they have done so. So just quickly to talk about what NRAO does, first is we sort of have 4 basic areas. What we call zone regulatory services. This is the regulation of 3 different areas. The National Radio Quiet Zone you may have heard of, which comprises most of West Virginia and part of Virginia. The Puerto Rico Coordination Zone is located around the Arecibo telescope. And then the New Mexico Radiodynamic Zone is a region around the Very Large Array and the Pi Town antenna of the Very Long Baseline Array. There's spectrum monitoring and mitigation. So this is where we try to kind of track what people are doing around our telescopes, and if there are, conflicts, to try to resolve those. And one particular device that we're working on is called the Advanced Spectrum Monitor. I'll tell you a little bit about that. But more generally, we have what are called interference protection groups at our sites, both in Green Bank and in New Mexico. A big area of spectrum management is also spectrum policy. And so my colleague Harvey List actually is involved in meetings of the International Telecommunications Union. And we regularly participate in presentations for a bunch of national spectrum organizations. And then finally, for NRAO, we have an area called spectrum development projects. These are sort of outside funded development projects where we're trying to kind of have as a proving ground for new ideas. And of course, the very important work that Valarie does would come under those development projects because the educational and curriculum projects we do are mostly funded by outside organizations. I won't go through all these people, but I just want to show you a quick snapshot of this slide to just show you that we do have a lot of people involved in spectrum work at NRAO, all the way from Harvey List, who is our spectrum manager, to one of the newest additions to our crew, who is Dawn Pattison, who is a spectrum software engineer. So she's working on a couple of projects, and I'll show you one of the things that she's working on. And then in addition to these people, there are a whole host of other people who we call upon for information and data from time to time who aren't specifically supported in our division. So the three kind of details I just wanted to share with you are three projects that are currently comprising a lot of our work. One is called operational data sharing. This is a system that we've been developing that allows our telescopes to share in almost real time with satellite constellations what we are doing, where we're pointed, what frequency we're at, and they then use that information to adapt their constellation, basically stay out of our way, which is a remarkable thing that they're able to do. The Advanced Spectrum Monitor is just sort of a passive monitoring device that allows coverage from 1 to 50 gigahertz. So you can see that's a limited portion of the spectrum, but it's also much more of the spectrum than spectrum monitoring devices have covered in the past. And it also allows not only tabulation of the RFI that's there, but also the direction it's coming from. And I'll show you a little bit of detail about that. And then finally, on the software side, we're developing something called the Dynamic Radio Interference Finding Tool, or DRIFT. That's a web-based unified GUI, graphical user interface, to view RFI scans from multiple instruments. So I'll go through each of these and just sort of tell you what we're working on. So this graphic on the right kind of describes how operational data sharing works. If you imagine the satellites, this is 3 of now 6,000 satellites that are up in orbit by SpaceX. They are providing internet service to various positions on the surface of the Earth. And so zone avoidance is one way they sort of stay out of our way, which is that they don't illuminate our actual site where our telescope sits. So that's sort of their beam, right? Them beaming down to the Earth. Then there's our beam pointing up, right? We have a sort of sensitivity beam. So whenever we're pointed at a certain part of the sky, if they have a satellite that trajectory takes it through where we're pointed, then they can actually disable their downlink beams for a few seconds, maybe half a minute. And the advantage of having so many thousands of satellites in orbit is that the loss of the downlink from one satellite doesn't interrupt their service, right? And so they have this redundant setup. And then the third way we can avoid each other is frequency avoidance. So basically, that's another reason we share our frequency, is so that at perhaps sometime in the future, systems that are flexible could switch their transmission frequencies, right? They would say, oh, you're in L band, we'll switch to X band. So this is an example of how this works. This is from a paper from last summer, and I'll try to describe these two plots. So the first is time on the y-axis and frequency on the x-axis. And so this is a portion of the spectrum. You can see it's about 50 megahertz. And in between the dotted red lines is the 5 megahertz where they are licensed to downlink. And so you can see as a function of time, they're downlinking, and we see their signal in that 5 megahertz. And then it sort of disappears here when it's red, and then it kind of comes back again. Well, the reason over on the right is the same plot just as a spectrum. So again, it's kind of flipped around. This is time on the x-axis and now strength of the signal on the y-axis. So you can see as a function of time, there is this portion of time where the signal looks like it's about to take off. And the reason for that is that the dotted line shows how close they are to where we're pointed in the sky, what we call our bore sight. As they get really close to bore sight, they enter what's called the outer bore sight. And we can see that what their system does when they get into outer bore sight is they actually steer their beams as far away from us as possible. And then if they hit inner bore sight, which this little peak here is, they actually turn off their electronics. So it works. And it's kind of a remarkable system. And we're now testing not only the X band, which is where they downlink for internet, but also L band. You may have heard that they're starting to downlink for direct to cell service. So that is a challenge. The second thing I want to tell you about is this device called the Advanced Spectrum Monitoring Device. And so this device has 4 different antennas on board. And so 4 associated bands. It's sensitive 1 to 20 gigahertz, basically 20 to 30, 30 to 40, and 40 to 50. So this device is called the ASM2, Advanced Spectrum Monitor 2. And we've actually developed all of these electronics in-house. This sinuous antenna, which covers the bottom part of the frequency range, is completely manufactured in-house. We actually have built 1 full face, and currently the machine shop is building 3 more of these, so we'll have the other 3 faces filled in. All the electronics are machined, built in-house. We send out and have the boards fabricated, but otherwise everything is assembled at the Central Development Lab at NRAO. And the purpose of this device is to produce scans like this. So this is actually not from ASM2. This is from the first device we built that we were actually testing in May of 2023. And what you can see here are 2 colors, right? The orange is the RFI signals that we see at the Central Development Lab in Charlottesville. And the blue is the RFI that we see up at the Green Bank Telescope in Green Bank, West Virginia. And so the sad truth is that although it's called the National Radio Quiet Zone, the blue data shows you it is not perfectly quiet. And in fact, one place it looks pretty similar between the 2 locations is right here. And many of you may recognize that as the 2.4 to 2.5 gigahertz Wi-Fi band. And so Wi-Fi signals are clearly present at the Central Development Lab in Charlottesville. They're also very obvious up at Green Bank. These 2, actually, the low one and the high one at around 1 gigahertz and 4.4 gigahertz, those are airborne radar signals. So there's no way to avoid those, even in a remote location. So this is the kind of data we hope to come out of ASM eventually. Oops. I'm trying to advance my slide here. And this is what it looks like. We've had many conversations about the fact that unfortunately it looks very much like a trash can or R2D2 or, you know, pick your device. But yeah, it's an expensive trash can if that's what it's used for. Hopefully not. But you can see that first panel that I showed you, that's replicated on 3 other sides. And the power on arrival, basically the power that comes into 2 adjacent faces, gives you a rough direction finding capability. So this device has the ability to tell you not only where in the spectrum signals are, but also in what direction that signal comes from. And then the last thing I'll tell you about, because I think I promised Valarie 10 minutes, I don't want to go too much over time, is Drift. This is the Dynamic Radio Interference Finding Tool. So this is a web-based interface. And what we realized is that we have all this good RFI scan data from all of our telescopes, because the VLA out in New Mexico, the Green Bank Telescope in West Virginia, all these telescopes do RFI scans, right? When they have a little bit of downtime, they're not doing science, they do an RFI scan. And so what we wanted was a sort of intuitive way to look at those RFI data. And, oops. Why am I not able to? Oh, there we go. We were able to do that with this very nice interface that Don Pattison has developed. And you can see that this is a prototype, but it's fairly far along in its development. What this shows is even smaller segment of the spectrum. It goes from about 1 gigahertz to 1.8 gigahertz. And you can see there are pull-down menus. You can choose spectral or waterfall plot, both of which you've seen in this presentation, the telescope, the receiver, and then it'll kind of pull up the data sets that are available. You click on the data sets you want, and then it overplots them. And there are a lot of complex software challenges to doing this, one of which is that these are big data sets and they tend to overwhelm most plotting systems. And so there's a way to sample data. But what this shows us is something very interesting. There's actually the 1420 part of the spectrum. So this is the H1 line, which is a protected band for radio astronomy. Notice that this part of the spectrum is nice and clean. There's not much RFI there. But there are other parts like around 1.5, 1.6. These are GPS satellites, RFI. And then down here at the bottom are some ground scanning radar systems and navigation systems. Okay, so I'll end up there and just say that, radio astronomy in general has a lot of spectrum challenges, in particular, the advent of space-based RFI has kind of put a lot of our location choices from the 50s, 60s, and 70s, made them a little bit moot, right? Because the direction we're pointing, i.e. space, is the direction from which a lot of the RFI is arriving. But we're making coordination on a lot of fronts. We're really we have good communication going now between our sites. Zone Regulatory Services is very active. That ODS system I told you about is operational at the VLA, and we're getting close to operations for our other two telescopes. Drift is going to be a nice way to have a window on RFI databases, and that cool little R2D2 device is getting close to being deployed this summer. So I will stop there. And thanks very much.
Thanks, Chris. Now, there were some questions or some of the chat.
Yeah, I can look at those now.
Yeah, if you could answer those. I have a knee-jerk thought about some of those, but I'm going to let you answer them because you'll actually know the official answer.
Yeah, so yeah, phones don't operate at Green Bank, that's for sure, because there are no cell phone towers operational. However, the direct-to-cell operations of T-Mobile and Starlink and SpaceX may change that. Microwave ovens also are a source of problems. If you think of the area around Green Bank, it's actually designated as the West Virginia Radio Astronomy Zone. I actually read the legislation from the 50s that established it. It's kind of cool. What that says is that in an area of 10-mile radius around the Green Bank Observatory, that electronic emissions are not allowed if they interfere with the operations of the radio telescope. So that what that means is microwave ovens certainly. So truthfully, microwave ovens shouldn't be operated within 10 miles of Green Bank Telescope. We know that's not the case because we actually detect Wi-Fi networks. So there are ways in which emissions are happening. We just sort of choose our battles, right? Let's see, Faraday room in the visitor center. Yeah, that's correct. There's a Faraday. The entire operations room is a Faraday cage because of all the computers in there. And yeah, phones don't receive signals in there. Yeah, if we could see all that would be great. So I hope that gave you just a little flavor of spectrum management and spectrum activities at NRAO. I apologize, I can't stay on the line much longer. For your time, there was a question, how does NRAO coordinate with international parties interested in these bandwidths? Yeah, so there is an open question, right? Is that, if China builds a Starlink equivalent, which by the way they are, then how do we interact with those systems? And the truth is, we probably won't be able to, so if those systems get close to boresight, we will have issues, we'll have problems with that. Now, these systems are not going to be providing service within the United States, we don't think. But if they're above the horizon and they're serving Canada or Mexico, it'll create similar challenges for us. Yep. And in the same way, Starlink is not providing service in China, but they are now probably going to start providing service in South Korea. So for a Chinese radio telescope looking to the south over South Korea, they could have similar issues. So at some point, if we're going to protect radio astronomy internationally, that's a great question, Naji. All right. Well, I really appreciate the opportunity to talk with you all. I truly, truly, and deeply appreciate all the teaching and education and hard work that you do educating these students. And I'd love to come back anytime you guys want to talk again.
All right. Thank you, Chris.
Thanks, everybody.
Thank you.
Bye-bye now.
All right. So Chris has talked to you about all the technical things, and I get to talk to you about all the education things because it's how we coexist here. So let me tell you, now we're going to switch and start talking about some of the opportunities we have that you all can take advantage of. By the way, before I get started, to make it clear from the very beginning, everything that we have is free of charge. So there's no cost associated with anything. We are mostly funded by NSF, which was really good for us. And now, well, we'll see. But so everything is free. We have undergraduate curriculum. So these are available for any professors who would like to use them as either an entire course, so it's a 3-credit course if you put it all 6 modules together, or there are 6 2-week modules that can be used independently. And honestly, people who have used them are just picking pieces out of these courses. And so this course, it's called the Introduction to Spectrum Management and Science, and it contains recorded lectures from content experts, their reading assignments that they picked out. All the reading assignments and materials are free of charge. They've come up with in-class assignments or quizzes. There's even a final exam. And all that, you can download it, you can use it in your course, and we don't expect any payment from you for that. Now, because I recognized that it wasn't really being picked up by professors like we had hoped it would be, and we wanted to make sure that it was available to students, even if their professors weren't interested in using it. So I've been converting the curriculum into digital badge courses. So these are asynchronous. They're 10 to 20 hours to complete, depending upon the particular module, because it's the 6 modules that have been converted. Again, completely free to use. We ask people to complete them in 6 months, but if somebody can't get it done in 6 months, it's not a problem. We're welcome or willing to give them an extension on that. And the digital badges are the same content that is in the curriculum for the undergraduate. It's just been converted to make it asynchronous. So the in-class components have been removed. And so we only have 4 digital badge courses available. I'm going to go through all 6 modules. There are 2 modules that are currently available as curriculum, but they're not available as digital badge courses. And there'll be a digital badge course as soon as I find the time to do that. So we'll see how quickly that happens. We have a science fundamentals course. This was created by a professor at Virginia Tech University. And you can see there some of the topics that are included in this course. We also have an engineering fundamentals course. This one has actually been really popular with the NRAO staff who are not engineers. And again, the same individual from Virginia Tech has created that for us. It's a great course. These courses are all designed, primarily, it's tough to tell, at a level. They were originally written for someone who was, say, a junior in college. However, I mean, that really depends as far as who could master this course. It depends on how willing they are to dig deep, if they're having troubles with it, how motivated they are. So there is an app. All you have to do, again, this is free for anybody. There's a little application that people have to fill out. We do have prerequisites for these courses because we do want people to be successful, but they don't require formal courses necessarily. So like for the engineering, the requirement is that you've had 2 years of physics. If you haven't had 2 years of physics, but you had some experience that would be equivalent to that and somehow, then that's something that can be worked in as well. We don't just have things that are science-based, because spectrum management really goes across a lot of disciplines. This is actually a legal course, and this was written by Lisa Sockett, who is a former Fed chief. in DC, and she wrote the Legal and Regulatory Foundations of Spectrum Management. And I'm going to tell you, this is an exceptional course. She is very personable. It's very approachable by anybody who is not, this is not intended for lawyers. This is intended for anybody who is interested in learning about the legal aspects of spectrum management. We also have an economics course, Spectrum Economics and Market Tools, and this is written by Sarah Lamb. Sarah's actually is creating a graduate level course for us on spectrum economics. So this, again, is intended for anyone. It's not just people who are economics majors. This is not yet been transitioned into a digital badge course. That will be, as I said, coming as soon as I can do it. But this has got some really great non-STEM related information about spectrum management. So again, even these non-STEM, so the non-science, the non-engineering components really come together in spectrum management. So the spectrum management, as I said before, is a field that a lot of students can go into. I was actually looking this up for a former student we had, and it is fairly easy for someone with a 2-year degree to get into spectrum management at the level of, an engineer and working at a cell phone company, even the train companies hire a lot of these people. It's easier for somebody to get in at the 2-year level than it is to have a 4-year degree in physics. So that's something for your students to look into if they're interested in it. And again, all types of students, not just the engineering and physics students. Spectrum management methods, this is another module that has not yet been transitioned. This really looks at how do you manage the spectrum. So looking at some of those things about how you can do spectrum sharing and how these different groups work together. So the government groups, the labs like I work for, the commercial groups, how they all really interact to make spectrum management work in real time. So in addition to the undergrad curriculum that we have available, I heard some of you are teaching in high schools. We also have middle and high school curriculum that is available. There are 30 lessons. They're all, again, within the spectrum management realm. So it's not just astronomy, although there are some astronomy, radio astronomy particular lessons available. There's a really great one that actually models radio astronomy using an umbrella and play balls, like from a ball pit type of thing. It really is remarkable how accurate that modeling exercise is, and it's a lot of fun. So we have these 30 lessons. We have them in both English and Spanish. It comes with a very detailed lesson plan. So it's great for a beginning teacher. It comes with all the student pages, and it's been translated into Spanish, so we have it in English and Spanish. And right now, so for teachers who are interested and can teach this by September of 2025, I can buy the materials for the lesson that you want to use, and I can pay you $50 for feedback. So if you're interested in that, just get in touch with me for the high school teachers out there, and I will get you what you need to teach the lessons. So our student programs. This is something that unfortunately the current political climate has taken a hit on. We used to have more programs. That's really why I wanted to meet with this group. We had some programs that were particularly, dedicated to the students you have, the minority students, the non-traditional students. Those have gone away. But we still do have programs, and your students are still welcome to apply for our programs, and we'd like for them to be part of them. So we have a NSF-funded REU that's every summer. This one comes with a lot of stuff. That's really fantastic. It's 10 to 12 weeks. They get paid travel, they get paid housing, and they get a stipend. That's rare for a student summer program. They can be in Charlottesville, they can be West Virginia, they can be in New Mexico, and occasionally they can be virtual. We really kind of phased the virtual ones out. unless that program really works. So like I'm going to have a summer student this summer who is going to be virtual because she's going to be creating a dashboard for our citizen science projects. And so she doesn't need to be in Charlottesville. She can be completely remote and do that. We have those still, a few remote opportunities, but most are in person. We also have non-NSF funded summer student programs. These come with the same things as far as the paid travel and the housing and how much they get paid. These are not as abundant. It has to be funded by an outside grant. I work on what is called the NRDZ project, National Radio Dynamic Zone project. And we've had money for some students in the past. There's another project I work on called Spectrum X, which again is really focused on all aspects of the electromagnetic spectrum, as far as the radio frequency portion of it. And there are summer programs for those as well. So those are just depend upon the program availability. Now, this is something that would be beyond the 2-year college, but my colleague who works with our student programs wanted me to share this with you because this is something you might want to pass on to your students. So your students who are perhaps graduating this May, this is something they could think about for this coming year. It's something new. It's called Cosmic AI. And we have these programs that they can apply for. The winter school that's coming up, starting in this year, we're going to have next year a summer school, and then eventually we'll get to the point where it'll be the online certificate for AI and astronomy program. This is a 5-year grant, so that will be toward the end of the grant. And here's some more information about the Cosmic AI Virtual Winter School, and I am happy to share this slide deck with all of you later. So don't feel like you have to write this down. This is a lot of detail that, again, is more for you to pass on to your students who are leaving the 2-year, college setting. Again, this will be the next summer, that we'll be having this in-person summer school in Charlottesville. Again, juniors and seniors, even early grad students. So if you think your students, you have some current students who are graduating, they really like AI, they like machine learning, that's something they're interested in, this may be something that they will want to think about applying for in the coming year.
Valarie, just
Yeah.
to interrupt you,
Sure.
there was a question in the chat about digital badge and what a digital badge course is, and I had tried to define it as a way of credentialing that's less formal than like an accreditation process. But do you want to talk a little bit about just what a digital badge course is?
Yeah, I think actually, Chris, you did a great job of explaining that. That's it exactly. When I got hired at NRAO, my boss, who is retired since, she told me she wanted to create a university, but we're not a university, right? We're a research institution. And so one of the challenges was accreditation from our side. And so we really, it is not a step we're able to make to get things accredited. So we step around that by hiring people who work at accredited universities to create our content. And then by offering it as far as a digital badge where, it just really, it's not going to give anybody a credit. You don't get a credit at your institution for doing it. You do get that neat little badge you can put on your LinkedIn or whatever you'd like that shows that you have the initiative to take a course outside of a traditional university setting. These are university level courses. So these are, I'll be honest, they're hard. The engineering class, I'm not an engineer. And I had to go through it because I had to set up the quizzes and things like that. And it's very, very difficult from a non-engineer's point of view. So these are vigorous courses to take, but you just can't get a credit for it.
Vanguard Hydrulo can improve daily abilities and reduce muscle weakness with a treatment plan that's personalized to you. Do not use Vanguard Hydrulo.
Okay, So now I'm just going to talk briefly about the visiting. You can look on this. The Very Large Array and Green Bank and West Virginia, you can visit with your classes or your families, whichever you would like to do. To visit the observatories, they have regular open hours. You can go during those hours. Now, if you want to take your class to either of these locations, they do require that large groups, I think that's about 10 people or above, do need to make special arrangements to let them know that you're coming, and so they make sure they have enough staff on site to be able to help you with a tour. There is a possibility of getting like special tours, excuse me, like this behind the scenes, and some people you can take your class out on one of the telescopes and actually walk on it. Those are hard to get. There's limited availability. You're gonna have to arrange those well in advance with an NRAO staff member. So if you could get like a scientist to work with, that would be the best way to get one of those special tours. All right, so let's break here before I go too far. Are there any other questions that weren't mentioned? Oh, Chris had that one question. Was there anybody else that had a question before I move on to the citizen science?
The summer research assistantships, would that be appropriate for high school age students, or is that more aimed at high
Yeah,
school?
we don't have anything for high school age students at this point, and unfortunately with the funding situation we are finding ourselves in, it's unlikely we're going to be able to expand. So these are available from anyone who's a freshman through we don't want them to graduate. So through a senior who, if they're not going to graduate and
And then where were where are the different lessons that you had available that looked like some of those could potentially be high school appropriate?
they are, and I'm going to go ahead and drop the webpage in the chat. And Supernova is our headquarters for all e-learning and educational materials. And so if you look on there and you go to the right, just go to programs and then select the teacher resources. You should be able to find them. And I can, not looking at that page, but in just a moment, I can tell you specifically what the title of the page is. But they're all there. The citizen science are there, the courses are there, everything is there.
And sorry, last, but you said reach out to you if there's something that maybe you could help with funding for materials for that. Is there contact we can get you at?
I will also drop that in the chat. Yeah, you can just send me an email and be like, hey, I would like to know more about that. And I can set you up with that.
Thank you.
You are very welcome. Are there any other questions? All right, we're going to move on to the citizen science project. That way we can actually do something. You can, instead of just listening to me. So we have two citizen science projects. One of them is brand new and isn't launching yet. And then we have Sensing the World Around You. It's our current citizen science project. This one is really intended to get people more familiar with the uses of the radio frequencies in their area. And the website, the supernova.org, it has this project on it. There are 3 different activities that you can do. One uses an RTL SDR dongle. Actually, you can do a number of activities with that. There's an Android phone activity, and then there's activities for Android and iPhones. So with the dongle, which that's what you see on the screen, there you can investigate local broadcasters. So you can pick up things like construction workers who have the radio systems. You can pick up some hospital communication if you happen to be in Charlottesville. I know that you can do that, like the pagers within the hospitals. You can track aircraft. So that actually has become very popular. You know, you see the aircraft moving around. You can receive satellite signals, and you can do so much more with these things. There's so much you can do with an RTL SDR dongle, and I have them to give away. So if you have a computer that meets the requirements that are on the screen, and so that it does have to be a Windows, it doesn't work with Macs, and it's an Apple. That's the same reason why some of the cell phone app I have that works on an Android doesn't work on an iPhone. So I have these to give away. I do want to caution people that these use open source software. So you need to be willing to download things and install programs on your computer that can be a bit challenging sometimes. You know, sometimes they're a little persnickety. And anyone who's ever done any work with an RTL SDR dongle, they all usually nod at me going, yes, yes, they are. So if you are willing to put up with the persnickety nature of that open source software, and you have a computer that that has these components, then again, I have a dongle I can give to you that you can do those parts of the activity. However, you don't have to have one of these dongles. You can do it with an Android phone. If you have an Android phone, there's an app we use called Wi-Fi Analyzer, and you can actually detect the Wi-Fi signals in your area. Makes a really beautiful picture on your phone, and just gives you an impression of how many routers are in your area. This actually was on the screen, the picture you see I was living in an apartment in Charlottesville, where the internet was included in the rent, so everybody had one. I didn't take a picture, but out here I moved to be near my parents, and let me just say, this picture is very different here in rural America than it was there in Charlottesville. Now, this is when I asked Krista to ask you all to have your phones and even try to download the FCC speed test app. Now, what that does is it tests the speed of your mobile broadband. And so this is a project that was funded by Spectrum X, and we thought about developing our own app. But to be honest, the FCC app does everything we wanted it to do. And it actually can allow the government to contest with those carriers about the product they're providing to you. So I'm going to stop sharing. Did everybody have a chance to download the FCC speed test app? All right. So what I would like you to do is actually, and you're inside, and that it's going to tell you that it's not going to actually count. They want you to be outside. And so to contest your service with your provider, you have to be outside or in a moving car. But you can't be inside. But so there's a quick test, and the quick test doesn't require you to put in your information. The others do, or a quick check, I guess is what they call it. And so you can just do it really quick. And what I would like you to do is just do a quick check, and then you should have access to that Google Doc to put in your information, so we can just take a look at the differences. So just to give you a little information, obviously upload and download, that's pretty easy to understand. Latency is the time it takes for your signal to get to the test server and back to you. And I actually tried this earlier, and it was in the hundreds of milliseconds, which is the highest I've ever seen it. So I'm not sure what's going on with the FCC at that moment, but it wasn't good. but they seem to have fixed that. And the jitter is a variation in the latency. So the higher the jitter, the more unstable that connection is. And on your phone, it should tell you at the top, if you're using 4G or 5G. And there, I know there still are some 3Gs out there. I don't have the failure rates for the 3G. I do have the failure rates. Again, you're not outside, so this really doesn't count as a failure. Just so you know that for 4G, and this is download versus upload. So 5 megabytes per second for download and 1 megabyte per second for upload. That's like the standard, and anything less than that is a failure. For 5G, 7 megabytes per second download and 1 megabyte per second upload is a failure for 5G. So just for your information, that if you want to do this later outside, so you can challenge your carrier. Now, I will tell you that the FCC, they state that they will challenge the carrier when a certain number of people in your area have done this, and they found that the test had failed. They don't specify what those numbers are. Mine always fails. Mine is never what it should be. But I live in a cornfield, essentially. So
What were the fail numbers again? I missed that.
for 4G, it's 5 megabytes per second download and 1 megabyte per second upload. And for 5G, the upload number is actually the same. The download number is 7 megabytes per second. So this is part of our citizen science. We are actually developing a new platform on a web page where you can upload this data. We have it now on Supernova, but we're going to make something a little bit fancier, because on Supernova I have Google Docs. But so that's coming soon. Think about participating. I mean, this is also a really great classroom activity. You can have your students do this on campus or at home. I will say one thing: we've had some professors and teachers do this. You might want to leave the cell phone company off, or even the make and the model of the phone is sometimes interesting to look at from a scientific perspective. But you might want to leave that type of qualifiers off, because there can be some embarrassment about not having the greatest, especially the younger your students happen to be, the more true that probably is. So that can be just something to take into consideration. But this is interesting to see, the differences among, the latency and the speeds. I can definitely see that my speed is very low compared to everybody else here in the cornfield. But that probably makes sense, because you all are in cities, and that you're going to have 5G. In fact, does everybody know, is everybody else? I'm running 4G. I have 4G out here. I would probably never have 5G. That's because of the way 5G actually works. It doesn't really make sense to have 5G in the country. Does everybody else have 5G? I'm assuming. Any other 4Gs out there? So that really explains a lot. So that's just a taste of the citizen science project. Like I said, we have a place on Supernova. You can upload your data. We're going to have something fancier by the end of the summer. That's what my summer student is developing for us. But, it's kind of fun. And if you want to try out the dongle, let me know, and I can get you one of those, and you can try those out as well. All right, we have enough time, because I really do want I have something else for you to try. And I want to make sure we have time for that. But are there any questions about this project before I move on to the next one? Let me check the chat really quick to make sure. Okay. Oh, there was another 4G person. All right, at least I'm not alone. So we have a brand new citizen science project, very exciting. I want to tell you about, and I want to give you a chance to try this one out. So first of all, let me grab the right link, because I'm going to give you a link for this. So we have this brand new project. Like I said, it's hot off the presses. It's a sneak peek. We're not even going to pilot it until starting in June. So you guys are getting the first view. We're calling it Signal Sleuths, and it's all about uncovering radio frequency interference. Chris was telling you about the interference that we see, and that interference is going to be growing. And so what we're looking at, though, is finding unusual signals. So we're using an antenna at Green Bank, but we're not using the Green Bank Observatory antenna. This is the thing that, excuse me, my neighbor's mowing grass. My allergies going crazy. This thing that kind of looks like a lawn chair or a trough is a radio antenna. It's made by a company in Canada. It actually is, there's an observatory in Canada. This belongs to them. And they've made arrangements to put it on Green Bank's land. This is an outrigger, so this is not the main antenna. The main antenna in Canada actually has 4 of these troughs. So this was originally made to study pulsars. But what we found, because of the structure of it, that it is really good at looking for RFI. It doesn't move. I mean, and it's monitoring the same part of the sky 24/7. So we decided to use the data from this. Plus, they send us the data every day in a very nice visual format, so we thought that was perfect. Oh. So I forgot that I don't want to tell you a lot and want to actually send you to the website. So before I send you to the website, though, this is, Chris mentioned the quiet zone. This little star here is Green Bank. And so this is supposed to be a radio quiet area. There aren't supposed to be a lot of signals here. You'll see that that's not at all true. There are a lot of signals there. Again, this antenna is picking them up every day. TV stations are out of control in that area. But we're looking for the other signals. So what I'm going to do is send you to the website, and you're going to go through the tutorial, which is going to tell you all about it. And then you're going to try to identify unusual data within the RFI. So with no further ado, because I want to give you plenty of time to do it, I'm going to just drop this in the chat. And that should take you to a Zooniverse page, and you should be able to, you can either learn more or you can get started. If you click on the get started, it will take you to the data, and it will take you to the tutorial. I would suggest highly that you do the tutorial first, and then you go to the data. So I'm going to suggest that you take the next 10 to 12 minutes to try that out, and then we'll reconvene here. So hopefully you notice, and again, that data is collected in what is called the radio quiet zone. It's not so quiet. There was a time when it was, but it's not true anymore. The biggest part, and that's not the entire, radio frequency spectrum. It's just a small portion of it. But you can see that there are a lot of television stations there that make up a huge part of that particular part of the spectrum. Did anybody have any thoughts while you were doing it? Did anybody actually get to the part where you're able to start identifying some of that weird data that may be out there? Okay, Joseph did. So anything that occurred, like any questions you have about it or any thoughts you had on this, what is very startling data? And as Chris told you earlier, when we get to the direct-to-cell satellite signals in West Virginia, that really is probably going to change this picture drastically.
So this data is, really what we're doing is trying to find the odd signals and
So, I mean, what it has in the tutorial is all the signals that we see all the time.
Mm.
What we're looking for, the help from the public, is finding those unusual signals, because some of them are very small, and so when you're looking at a very bright, very vibrant picture, it's easy to miss those very small signals. So we're looking for help identifying the unusual things so that we can then investigate them. So what happens in West Virginia when they get some of these signals is that we actually have a guy who drives around in the back of a truck. So somebody drives, he's in the back of the truck. It's probably not at all legal, but he's got this antenna in his hand and he's trying to pinpoint where these signals are coming from. And then we go and we just it's all about interpersonal skills, right? We talk to them, we try to come to understandings, and meet in the middle and talk about what's legal, what's not legal, what helps us, what's not helpful to us, and have those conversations. But we can't have those conversations until we actually know where those people are. So once we have a record of, hey, this person is emitting a signal, then we can know who that is, and we can talk to them, and we can try to mitigate that signal from that point. So that's the purpose of the project, is to help us find those unusual signals that we don't know about, so we can start working with whoever is emitting that particular signal.
How often does that person or people actually look at the data that people have, put a rectangle around? Do they look at that every day, or they look at it once a week?
Well, we're just getting started, and so we don't have any data. Like I said, this is brand new. We don't have any data at this moment, and so this will be given to them, and depending on how many users that we have, probably on a weekly basis. But if we have a lot of users and it's very popular, we may have to go to daily basis just to reduce the amount of new information they have.
This is completely off the wall, but I'm just sitting here thinking it would be kind of interesting if you picked up some signals that led to ultimately something illegal going on when the people doing the communication didn't know that they were in a radio quiet zone, or heard the words and didn't know what that meant, and were communicating, and didn't realize that their signals could be picked up like this.
Mm-hmm. And there are lots of them that are innocent. They don't intend to cause problems. Then there are television stations, like those ones that are actually the really bright white lines, the vertical ones. Those are 3 digital television stations that are just outside of the quiet zone, and they have turned their signal up as strong as it would go. And they did it intentionally. They know what they're doing. So there's some of them that are unintentionally causing us problems, and then there are others that really don't care.
What about ham radio? Would that show up?
It will show up. And because if you've been to Green Bank, it's surrounded by the mountains. And one of the people who is in charge of monitoring the signals in the area, he thinks sometimes the signals we see actually are ham radio operators that maybe have taken their equipment like on a camping trip or something. And so they're communicating, and they don't know. And so you'll see those signals though from time to time.
What happens if someone turns on their phone when they're driving through?
It causes a signal, so they'll see like a brighter, like little flip on the data. The data that is in this Citizen project doesn't have the cell phone signals. That's at a different frequency. But as far as at Green Bank, they do see those signals within the data when they're collecting radio astronomy data. They'll actually see that if they're that frequency, it will show up. It shows up as basically noise within the plot that people have to then remove. Although,
and is that noise present? I'm sorry. I was going to say, is that noise present even when the device it can't find a tower to communicate with? I mean, is the
Yes,
device
because
sitting there sort of pinging and hoping,
mhm,
hello, hello, is there anybody out there? Is that
that's
the
it
noise
exactly.
that they pick up?
Because in West Virginia there aren't any towers around, so they
Good.
can't connect. But the phones, yeah, no, they're reaching out continuously, trying to the phone home essentially and find their source of information.
So everybody has to be on airplane mode if they have a phone?
Actually, they would prefer you turn them off because even in airplane mode, some of them, I think the iPhones particularly, are noisy little things, and they are continuously emitting radio frequencies. That's probably an Apple characteristic. So they really would prefer that you turn them off. Well, I see we're almost out of time, and I want to be respectful of that it is Friday, and I know everyone, hopefully you have plans. Now, I know Chris said she's got a survey for you all to fill out. I just dropped another thing in the chat that if you have a chance, and whenever you get a chance to do so, if you could fill that out for me, I would greatly appreciate it. But it has been a pleasure to be here with you on this Friday afternoon. I'm so glad to finally arrange this. I think you all are doing great work, and I hope that we can continue this relationship with NRAO.
Thank you so much, Valarie. Really appreciate learning about the resources at NRAO.